So this lesson is the start of Standard 4. So our essential question, what types of measures of center and measures of spread are there? When do you use each one? So we'll start with measures of central tendency. Now I know you may have done some of these before, so this is a great refresher. And then we'll talk on the next slide about measures of spread. So the first one is a mean. To find the mean, you just add up all the numbers and divide by how many there are. Mean is another way to say average. Okay, they mean the exact same thing. So you add up all the numbers and divide by how many there are. We usually use the mean when our data is symmetrical. And when we talk about graphical displays, we'll talk more about symmetrical data versus non-symmetrical data. So let's go ahead and show how we would find the mean. So it says add up all the numbers. So that means 10 plus 3 plus 7 plus 9 plus 8. And then you divide by how many numbers there are. In this case, there are 5 numbers. Now we do have some notation for the mean. We usually use an X with a bar on top. So if you see X bar, that means you are looking for the average. That's the mean. So we'll add up all the numbers on top to get 37 over 5, which is 7.4. So this is our mean. Next is the median. So to find the median, you must order the numbers from least to greatest first, then it's the number in the middle. We usually use the median when our data is non-symmetrical or if you have some strong outliers. And the symmetrical data and non-symmetrical data is what the shape of the graph looks like after you are done. So I can show you a few examples. Symmetrical would look something like this. Non-symmetrical might look something like this. So in this case, we're looking for the median of the same data set. You must put the numbers in order first from small to large. Once you get the numbers in order from small to large, you just look for the number in the middle. So it helps to count from the outside edges. So you start on the outside edges with the 10 and the 3, 9 and the 7. That means the 8 is in the middle. So our median is 8. Another example, it's nice when one of the actual data numbers are the median, but if you have an even number of data values, then the median is not necessarily one of those numbers. So we've got 3, 7, 8, 9, 9, and 10. So now when we look for the median, start on the outside edges, we're working our way to the middle. The median is between the 8 and the 9. So you have to find what number is between the 8 and the 9. So to do that, you add up the two numbers and divide by 2, since there's two numbers that you're adding. So in this case, our median would be 8 plus 9 divided by 2, which is 17 divided by 2, which is 8.5. So that's our median for our second example. Next is the mode. The mode is the number that appears the most. More often we use mode if we're looking for categorical data, which item occurs the most. But we can also use it with numerical data where we are looking for the number that appears the most. So if we look in the data set that we had before, every single number appears exactly once. So if everything appears the same number of times, then you would identify the mode as none. There is no mode. Those are your only two options, none, or you can say no mode. Now here's another data set. That was the example 2 that we used above. And if you notice, the 9 appears twice. Everything else appears only once. So our mode in this case is 9. Next, we will look at measures of dispersion. Dispersion is another way to say spread. How spread out is the data? So we had 3 measures of center. We also have 3 different measures of spread. So the first measure of spread is our range. The range is the largest value minus the smallest value. We can use this with any set of numerical data. So we look at our data set to find the range. You take the largest value, in this case 10, you subtract the smallest value, in this case 3, so our range is 7. Next is the standard deviation. So we use standard deviation when we have symmetrical data. That's the same time we use the mean. So if you're using the mean, you would use the standard deviation. They go together. Our standard deviation calculation, we use sigma. So that's a Greek letter, sigma. And then there's a shorter way to write the formula, but it requires a lot of notation. So we're going to show the long version. You would take each of your data values. So if we look at the data above, so if we look at this data right here, this would be x1, x2, x3, x4, x5. So in this case, we have 5 data values. So you would take your first data value, subtract the average, which is x bar. So we talked about calculating the average on the previous slide. Then you're going to square that and add the next data value. So then we take x2, the next data value, subtract the average, and square it. You keep going until you get to the very last data value, so I'll call it xn, subtract the average, and square it. And then you divide all of that information by n. That's how many numbers you have in your data set. You would do all of the subtracting, squaring, adding, and dividing by n first, and the very last thing you'll do is take the square root. Now, you'll be happy to know I will not make you memorize this formula. This is the only formula that I usually write up on the board and let you use during a test. I just want to make sure that you are able to use the formula and calculate standard deviation. The third measure of dispersion or spread is called the interquartile range. And that's where we take the third quartile minus the first quartile. We usually use this with non-symmetrical data, just like with the median. So if you're using the median, because of the type of data you have, you would be using interquartile range to describe what's going on with the data, the spread. We will talk in more detail about the interquartile range and what quartiles mean and how they're all connected when we talk about box plots. But I wanted to give you an introduction. It is one of the measures of dispersion, so you have all 3 measures, and we will review and go over them again when they come up. So standard deviation we will talk about more in next class, and interquartile range we will discuss further when we talk about box plots. Just so you have the general setup, there is an abbreviation for interquartile range, so we usually just call it IQR for interquartile range. And that would be the third quartile, so we call that Q3, minus the first quartile, which we call Q1. So that would be the shorthand way of writing the formula for the interquartile range. I don't have any practice work at the end of this lesson. Make sure you get all your notes. Don't forget on the left column to put in your study questions. And then at the end of your notes, write a summary for the essential question. And we'll see you in class.